I'm audible?
Yes, sir.
Yeah, I will start now. Okay, good morning, all of you. Today's class will discuss training and test set. This is very important in our machine learning model. We need to train some data and as well as to will go for as a testing as well. In the same set of data, we divided some training set and some portion is a test set. Normally, as you are aware that training set will be more data is required and test set will be as a less. That is depends on application. We'll divide as a two portions like 80%, 20%, or 70%, 30%. Depends. More or less, in general, we can say that training data is the more data. And after this, we'll go for an evaluation because once the model is ready, we need to analyze the evaluation, whether it is perfectly all right or is there any error. And by means of some analysis, we need to identify the evaluation of the model. So first we'll discuss the training. As you are aware that machines to run has a huge amount of data into predictions. So when the data is trained, then if we give any new data, it has to predict. These predictions highly depend on the quality of the data. Now the model is a layman, like I assume that. If you give perfect data to train, like a teacher and student, if teacher is good, automatically student will learn better. If teacher is not up to the mark, then automatically your student performance also will be poor. In that aspect, we can say that if the data is quality data, and then the performance will be better. It will predict more accurately. If not using right data for our model training purpose, it will not generate the expected results. That means our prediction is going for error wise, or it will not predict accurately. In all the normal case of machine learning projects and all, it divides the original data into two parts. One is a training data, another one is a test data. Train our model using the subset of the original data set. That is known as a training data set because in a huge data set, normally what we'll do is we have to divide the data set into two parts. It may be, features. Any number of features may have, and then these are all the features. Let us assume that in the output side we may have the output of the data or target data. If it is supervised learning, label data will be there, and we need to divide this into two parts. One part is for training, and it will be more normally, and testing part will be very few data sets are sufficient to test. And one more thing we need to take care of that while you are selecting, you should not take suppose huge data you consider as month-wise data. Let us assume that in the first month to 12th month, January to December data is available with you. And if you take up to 10th month data is for training and 11th and 12th month data is testing, then your model prediction will get the wrong answers. The reason behind is it is not mixed with all the data. But once the new data comes in the month of suppose December, because the model is not trained the December data, because whatever data you are taken up to 10th month data only, if you train the model, then model is not aware that what is the scenario in the December month and so on and so forth. That's why what will take is when the model is available, when the data is available, you cannot take upper side portion and a lower side portion and the bulk of the data. What will you mix the data and will pick up randomly? Some portion of the data is training purpose, some portion of the data is a testing purpose. Otherwise, if the model is not trained, all the possible options, if the new data comes in, that may be unknown parameter for them, so it will predict the wrong answer. That's why we then evaluate its ability to generalize a new or a unseen data, or you can say that new data known as a test set. And this is the train and test data sets are the two key concepts of machine learning, where the training data set is used for fit the model or to train the model or to develop a model, and test data set is used to evaluate the model. The reason in this is you train the model and the test set also, you may have the outputs, but if you give data, whether it is predicting correctly or not, because for that also answer is known to you. If you test the machine, suppose 2 and 3 is given, and training data is additional data, assume that so far whatever data you are given, training data input variables as well as the respective output variable, and then if you test the model 2 plus 3, the results is known to you from the data set is a 5, and if the predictive model also, if it gives 5, then the test set also is completed accurately. Then if new data comes, you don't know what is the answer, but new data comes from 10 and 20, if you give input, then proportionately whatever the equation is developed, that will give as a result. That is the prediction data. And why the training data set is required? It is a bigger in size, subset of original data set. I already mentioned, data sets will be as a huge data set. In that is a bigger portion we consider as a training, which is used to train or fit the machine learning model. Fit the machine learning model in the sense you have to fit the appropriate mathematical equation to develop the model. That is the reason we can say that in turn, based on the data, the model has to develop their own equation appropriately relevant to the input data set. And the supervised learning training data contains labels in order to train the model and mark the predictions. Prediction is nothing but there in the output side, whatever the supervised learning model is there. Whereas in the case of unsupervised learning, training data contains unlabeled data points, because in unsupervised learning, we have only the input data. We don't have the output data. That means target data or labeled data is not available in unsupervised learning. Inputs are not tagged, means what is the output for that? It is not tagged. Models are required to find the patterns. In unsupervised learning, we need to find only the patterns from the given training data set in order to make the predictions. Suppose, as I shown you in the previous, if you give some symbols or data points in the different, not only the symbols, even some values also you can give it. If you mix this fashion and the model, if the prediction comes like this is the shape, then it is which group of image. So that may be in the circle fashion or maybe in the triangular side, it will be categorized based on any of the algorithm, k nearest neighbor or whatever clustering algorithm. K means clustering and all. We can able to use that. So in that, we can see that models are required to find the patterns in that unsupervised learning. Type of training data. Model is highly responsible for the model accuracy. So here the thing is, as I said initially, the type of training data is based on that only model accuracy will be depend. If data is clean data, or sometimes if data missing data also there in the data set, if we train the model using that missing data, then also we'll get a lot of errors and model accuracy will decrease. For that reason, we have to do pre-processing the data, and wherever missing data is there in that particular column, average you can take it, or something mechanism, different kind of things are there, or you can delete that row as well. Something there is a different kind of mechanism you have to use to find the, or you can the pre-process or clean the data. Better the quality of training data, better will be the performance of the model. So training data is approximately more than or equal to 60% of the total data set. Total data sets are 1,000 instances. In that 16 percentage of instances will take it as a training. It is a minimum normally. We'll take it as a 80% or 70% of the data. We'll call it as a training data set. Next one is, what is the test data set? Once we train the model, what we call it as with the training data set, it is time to set the model with the test data set. So what is the instance is here? Once the model is trained, then what we have to do, we have to test the model. There is a evaluate the performance of the model, ensure the model can generalize with the new unseen data set. Now, model is trained and you already allocated some portion of the data sets for the testing purpose. And if you test the model using this data, we can easily understand what is the accuracy of that model or performance of the model. And once if you the testing model also done, testing also done, then the model will be ready for our predictions. The test data set is another subset of the original data. As I said, our original data set consisting of a trained data set as well as the test data set. Trained data set will be the more portion, or you can say that more than 60% of the data sets belongs to the trained data set, and test data set will be less quantity, or you can say that finally it is a subset of the total data set, which is independent of the training data set. It is not some whatever we divided for the training purpose completely, the data sets will train, and in that we don't take it to the test side. We take it as other portion of the data. We'll consider as a test side also. Is the original data set that contains the each type. This is very important, as I mentioned earlier, each type of scenario for a given problem. So I mentioned, from January to December data, weather data. Suppose if we want to train the model to predict the future weather. Suppose if I divide the data set January to something October data for training purpose, and testing purpose, if you give the rest of the months, and if you try to predict something, then the model will not give accurately, because model doesn't know what is the weather condition in the month of November, December and all. That's why what you have to do is, while you are giving the data for the training purpose, it must contain each type of scenarios. So not only that example, any other example as well. Suppose you want to train height of the people. For all age group people height, you have to give it. Then only they can predict example. Suppose if you train the model for the aged people, and you are testing for the children's, and you predicting some other age, that will leads the problem. That's why while you are training itself, you take some instances for the aged people, some instances for the middle class, some instance for kids, and so on and so forth for men and women. You make sure that training data set must consisting of the each scenario. That's what I'm insisting there. And usually, test data set is approximately 20 to 25% of the total original data will consider as a test. Obviously, rest will be as a training. Suppose if I take 20% is a testing case, 80% will be as a training case, and vice versa. I mean, it should not be vice versa because training must be more and testing must be less. The means is 25%. I'm telling 25% is a test side. The rest will be as a training side like that. We can also check compare the testing accuracy with the training accuracy. Here also important. You can see that compare the testing accuracy with the training accuracy. So both we need to identify that will lead some problem as well. I will tell you. Accurate our model is with the test data set, again the train data set. In that case, the problem is there is a overfitting. Suppose if the accuracy of the model training data set is greater than test data set, this we call it as a overfitting. So that means if the model is giving accuracy is more for training data set and is accuracy is less for test data set, then we can say that it is a overfitting. Now, the test data should represent or a part of the original data. This we already discussed. It should be as a part and it should be large enough to give meaningful predictions and need to split the data set into two parts. What is that? Splitting the data set into train as well as the test is one of the important part of the pre-processing. While we are doing the pre-processing of the data itself, we need to split the data. One is a training, another one is a testing. By doing so, what will happen? We can improve the performance of our model and hence the better prediction. It will be improve the performance in the pre-processing itself if you do splitting and all. We can understand if we train our model with a training set and test with the complete different, this is also problem. You remember one more thing. This is very important issue. What it is showing is, suppose if you train our model with the training set and the testing is completely different set if I take. Suppose one training model for one data set from Kaggle or something GitHub or somewhere if you take, and same data only we need to use for the testing purpose also. But if one data is taken from Kaggle and other data set is taken from something GitHub of different data set, then automatically what will happen? Model will not be able to understand the correlation between the features. So because of this reason, what we should do is we need to take what you call it as training as well as the test sets must be from the original data set of one set only, should not be different data set. Now we can see this is the total data set. We divide the training data set some portion by seeing this image itself. It shows that more portion is a training data set, less portion is a test data set. That's what training and testing. Something is validation also in the part of that. So this is the total data set we are dividing into training part again, training and validation and testing. So this we should take care of that. If training set accuracy is greater than test set accuracy, then we call it as overfitting. It will come later point of time as well. If we train and test the model with the two different data set, then we decrease the performance of the model. That is what I'm insisting to do testing, because later units, what you have to do is we have to do algorithms, machine learning algorithms as well. But in this subject, we don't have Python programming to solve that algorithm. But what we learn is going to learn is here. We need to understand all the algorithms, how to do the, because problem is given, they may ask you to predict this solution. Then we can easily write a program, solve the problem for the particular solution. For that simple problems will give you to identify the predictions using supervised learning, unsupervised learning algorithms, and so on. That we'll see. Hence, it is important to split the data into two parts. We can easily evaluate the performance of our model. So if the performance is well with training data but does not perform well in the test data, then the model may be overfitted. For splitting the data set, we can use normally, if we go for programming part, we can see that some quotation, or you can say that how to write a Python program to split the data set. In this, what we have is train underscore test underscore split. It's a function of there is a scikit-learn is a library. From that, we have to import that. You can see that from learn that model, the sklearn that model underscore selection import train test split, that is available in that sklearn. From there we can split the data in this fashion. This is the keyword, or you can say that program part we are to write to split your data into this type of division. X train test, X train X test, Y train Y test, and we are splitting X comma Y data in the portion of that way. And first line of the above code means this one. What we have, import the sklearn library. By using this statement, we are able to import that. And second line, split function, the passed 4 arguments, which first two are of arrays of data, and second two of test size, for specifying the size of the test data. Now what we are specifying, 20% we specified. Then by default, rest of the portion we call it as a training purpose. And the test size will be like this. We can use it, any of this, 50%, 30%, 20%. Preferably, we'll take it as a, in this notation, between this only, we'll take it as a ratio of training as well as the test sets. And we'll see training data versus testing data. Training data is a subset of original. Of course, testing data also subset of original only, but from that percentage may be differ. Whereas testing data used to check the accuracy purpose, whereas training data used to create as a model. And the training data is generally large in size compared to test, and general ratio of splitting. This is the general scenario. It should not be less for training, 80, 20%, 70, 30%, 90, 10%. This is the ratio of training and testing data. And training data is well known to the model, as it usually train the model, whereas test data likely unseen or a new data. This is what the different actually. In a training data, we make use of input and output, and we are teach to the student +2 +3 is equal to 5, you are seeing there. But the test case, what we'll do is we will ask the student to tell the answer 2 + 3 is how much. This is the way Because if training data is perfect and the model is trained perfectly, then your answer will get expected answer may be correct. That way we have to do. This is the small comparison. Trained data, test data used to build the model in the case of trained data, and test case used to evaluate the model. Allocate the large portion of the data, but whereas in the test case, a small portion is sufficient, like what we discussed, 80% and 20% or so on and so forth. That is the day trained data will be large and test data may be small. And the further dividable for validation and won't be further divided, because once it is happened, training will go for validation. That's what in the previous diagram I mentioned, training, validation, and then testing. So whereas once the testing is over, then we don't require further validation and so on. And now we can see training and testing. There is a sequence we can notice. First, training data means feed the information. You can see what will happen once the model is trained enough with the relevant training data. It is tested with the test data. Now we can see, just a minute. Now we can see when the model is trained with relevant training data, it is tested with the test data. So now once it is trained with relevant data and we are going for a testing, we can understand the whole process of training and testing in 3 steps. That's what I mentioned here: feed, tag, and test. There are the feed is firstly we need to train the model by feeding with the training input. So now we are feeding or just giving input to the model. And second one is a define. Define means now training the data is tagged with the corresponding output. It is only the applicable in the case of supervisor learning, because corresponding output is known only for the supervisor learning. But whereas in the other model, transform the training data into text vectors or number of data features in the case of unsupervised and all. And third one is a test. We test the model by feeding it with the test data, unseen data set. And this step ensures the model is trained efficiently and can be generalized well. So this is the intern, the process is taking place. Now, while we are testing, you can see what will happen is more tag with the desired output and AI learning from human tag, then correct the output and model is ready. So once the output is correct, testing also over. At this point, the model is ready for prediction purpose. Prediction in the sense, whatever data set is available with you, we don't need that data for prediction purpose, because already we know that predictions as well for the existing data. But in future, if it comes in the, suppose we train the data in power system data for the 4 years data of the household consumptions, let us assume that for 4 years or 5 years data of one area, one township or somewhere, or I can say that any particular area, the data, monthly consumptions, everything, and pattern of instances of morning, evening, night. That way also, if you have the data and if you train the model, and in the next year, January, at 4 p.m., what is the power consumption in that area? if you give the command is like that for the ready model, then automatically it will give the accurate answer. This is the power consumption in that particular area for the specified date and time. That is the way the model is going to work. Because in the normal case, we cannot predict. We don't have the that much accuracy to tell what is your power consumption. Why it is happening? Because the model is already know in each weather condition in the last year, in that particular day or time and so on, in that area, how the year by year increasing the power consumption in the particular specific area or specific house. In that, if you know the past data, from the past data, the system is going to understand in the next year with that relation, they may be developed in the one mathematical relation by stating if we give something as a input in the next year or date and time, automatically it will predict your output. That's what so far we call it as a training and testing. Now, after that, after training and testing is over, what should we do? We'll go for as a evaluation of the model. Because model is ready. Now the model is with you because training is over, testing is over. But when you are using this model to any particular application, we must know what is the performance of the model. Like machine of the what you call it as a DC motor, let us say that. If the model is you design or like that DC motor is designed with your specifications and with your design analysis. Now, one customer want to buy that. What he will see, he cannot buy directly. He will ask you the lot of data, the performance of that. Under full condition, what is his efficiency? Or no load condition, what is efficiency? Or what is his particular efficiency under any particular load? So like that, we can able to evaluate that model, then only we make use it into the application. And we'll see the evaluation that ability to automatically learn and improve from the experience without being explicitly programmed. This is also important sentence. In this model, we are not giving any program to the model to train. We are passing the data only. In the terms of data, it will write a program. So in turn, there is a program, machine is going to develop the program to predict. Evaluate the matrix are used to measure the quality of a model. So now we have the specific matrices to identify the evaluation. And to build the model works on the constructive feedback principle, evaluate the matrix, explain the performance of the model. So now we'll see some of the matrices as well. To understand more about your model, it tells whether your model is memorized or learned. And make sure your model learns it is significant to use multiple evaluation matrices to evaluate the model. Because of model may perform well using one evaluation matrix, while the performance is reduced for the different evaluation matrix. And the use of evaluation matrix is critical and ensuring that your model is operate correctly and optimally. And why evaluation is necessary for successful model. How we can define it as a successful model? By observing some of the matrices parameter, accuracy, recall, precision, and all some of the parameters. If you evaluate, then based on that, we can say it is a successful model. As I said, overfitting and underfitting are the two biggest causes for poor performance of the machine. What is overfitting? Training accuracy will be more than testing accuracy that leads as a overfitting. And that's what I mentioned. This will occur when the model performance is well for a particular set of data. That means model performance is well for a particular data set, that is for call it as a training, and may therefore fail to fit the additional data, that we call it as a prediction. So while it is failed to predict accurately, that we call it as a overfitting, or in general word I can say that the performance will be more for the training set, and then performance is less for the test set. That's what. And underfitting occur when the model cannot adequately capture the underlying structure of the data. So insufficient data is there. It leads to the overfitting, in the sense the training data accuracy will be more than the testing. That will be as a overfitting. And underfitting is when the model cannot adequately capture the underlying structure of the data. That means the given data for training purpose, this model is unable to get one conclusion. It shows this is the pattern or this is the equation. If we give the input is something, and if I fit it into that equation, that will predict it. The performance of the learning system is important because learning systems are usually designed to predict the class of future unlabeled data points. So that is the reason before doing this process, suppose we are passing cat and dog letters in that. Maybe features are slight similar, but if we predict the wrong answer, then the use of the model itself will fail. That's what performance usually designed to predict the class of a future point only. The performance evaluation, you can see that there is a typical choice for performance evaluation. Error. What is the error of the model? What is the accuracy of the model? And then precision and recall. Based on these parameters, we can decide the accuracy or performance of the model. So error, accuracy, precision, or a recall. Now we can sample the method: training, a test, and k-fold cross validation. Of course, validation is also will give the performance of the model. In that, we may get later point of time on the, or in this unit itself, we have as a cross validation. We'll observe the cross validation to test the performance of the model. And evaluation predictions. So we want to make a prediction of a value for a target feature. Suppose example, X is our feature, one feature. Y is the observed value. And for each value of X, we may know what is the Y, observed value of the target feature of example X. And Y cap is the predicted value of target feature on example. So Y cap is a predicted value, and Y is the labeled value, and X is the input. Now we'll go for as a measures of error. Now what is the error formula? Absolute error means 1 by n modulus of f of x minus y. That y is the observed value. Means system, what is the observed value, that one, and we'll subtract the function minus observed value, and or you can say that an average of all the instances 1 by n modulus f of x minus y. Why the modulus is here? Sometimes observed value may be more, or predicted value, or you can say that existed data may be less. In that we may get the negative. That is the reason we call it as a absolute error, subtracting f of x minus y, and sum of squared error. So now we will take it as this is one instant. We will take sum of the instances. Let it be I is equal to 1 to n, and f of x minus y whole square. Here squared, that's why we don't require modulus there. Anyhow, even minus comes also, it will become as a plus with the square. Sum of squared error, SSE, and absolute error and squared error and the number of misclassifications. So this also one formula misclassification f of x comma y, the delta of f of x comma y will leads as a misclassification that will be identified if delta of f of x comma y is 1. That means that f of x not equal to y. Otherwise, it will be as a 0. So this is the way we can do. We'll see some of the evaluation matrices, different matrices for taking the classification, regression, and clustering. What are these methods? I already mentioned in the introduction, classification, or you can say that supervised learning methods we have as a classification and regression. And whereas in the unsupervised learning, we can have in the cluster, unsupervised learning is in the clustering. Then some of the matrices we can see there is a classification matrices, regression matrices, ranking matrices, and then statistic matrix, and then computer vision matrix, and NLP matrix. So like that, we have a lot of matrix to evaluate the performance of the model. But in this, we'll discuss some of the matrices like classification and regression and all. We'll go in detail of what is the accuracy and formula and all, what is the precision and what is the recall and mean squared error, mean average error. So like that, we'll go some of the things to get as a evaluation. Now, in that better understanding, I have planned to focus on the only classification and regression as per syllabus also. We can see classification and regression. These matrices will consider. And now first we'll move on to classification. So what is the classification matrix? It is a confusion matrix. It is important terminology in a machine learning algorithm. It is a confusion matrix. The confusion matrix used to determine the performance of the classification. For all classification problems, we'll go for as a confusion matrix. So in to determine the classification problems, we'll go for as a confusion matrix for a given set of data. And it can only be determined if the value of true values of the test data are true. So we have that in the different matrix fashion, true positive, true negative, like that, false positive, false negative. Error in the model is performance is of the matrix, hence hence we known as a error matrix. I mentioned here there is a classification and regression. In that we may have error matrix as well. So in that confusion matrix, there is a to determine the performance of classification model for a given set of test data, and if it is deviation, the measured value and then predicted value, I mean already there in the test data, in that we can easily identify the error. And since it shows error in the model performance from a matrix, hence it is also called as a error matrix. And for a two prediction classes, we have class 1 and class 2. The predictions we are to any number of classes, like, male and female, in that case, two predictions. And then other case, you can see that age group, we can say that middle age and then old age and kids, like that. There is a three predictions. Like that, we may have colors, the prediction, the given model, how to predict as a color. So like that, we have in a confusion matrix based on the classes, we can divide as a confusion matrix, either 2 by 2 matrix or 3 by 3 matrix or 10 by 10 matrix and so on into two dimension. One is the predicted value, another one is the actual value. So it is all about, as I mentioned, the error. So to find the error, so what we'll do is predicted value and actual value. number of predictions. Suppose if the number of predictions are 2, or you can able to find what is the predicted value and what is the actual value. In that predicted by the model and the actual values are the true values that are given by observation. Predicted values are those values which are predicted by the model. So now the whatever model is going to predict it, that values is a predicted values. Means once if you pass the input and he has to say, or model has to say what is your predicted value, and the actual values are the true values for the given observation. The prediction may not be correct always with the actual value. So in that scenario, we can see one example of here. There is a predicted class. Two classes are there, yes or no, or 1 and 0. In that, actual classes and prediction classes. The division, this will be very important in future also. Evaluation. There is a true positive, then false positive, then false negative, then true positive. In the sense, you can see one thing, true positive, true negative, then false positive and false negative. So like that, if both you can see that true positive means actual class and prediction class are the same. And other in the similar fashion, I given the example for this similar example. What is the true positive? True positive means actual class and prediction class. You can observe here this image. Doctor now is a model attached to that, and is saying that it is a you are a pregnant. So in that means is already pregnant. Then we can say it is a true positive. So means predicted value is true, actual value also true. So if both is true, then I can say that true positive. And what is true negative? So here you can see in this image, the what you call it as a you are not a pregnant, but he is a male, but saying that not a pregnant, but it may be true. But what is the negative in that impact is not at all possible to go for as a otherwise. So in that aspect, we can say it is a true negative. This the result is true only, but true negative because it is a we cannot predict in that case. So it is obviously it is a negative. So that is the one thing. And we can come to this case, both are false. So predicted value is false and actual value is false. So what is that condition? You are not a pregnant. So but actually it is a pregnant. But what is happening here? The prediction and actual is both is saying that wrong. So in that case, we can say it is a false negative. And otherwise also you can say in this case is saying the model is wrong. It is showing that it is a you are a pregnant. So in this example, or just for understanding, I am giving the reality. In that case, true positive and true negative, as well as false positive and false negative. It may not be 4 by 4. It may be any number of order of the matrix, but splitting is always these 4 parameters in the classification matrix, same in confusion matrix. In the confusion matrix, we have the 4 categories, true positive, then true negative, false positive, false negative. What is the true positive? Is an outcome where the model is correctly predicted the positive class. So it is a outcome where the model is correctly predicted the positive class. So it is predicting correctly. And true negative. True negative is the outcome. What we are getting is outcome where the model is correctly predicts with negative class. So because it is all a negative class. In this also is a negative class, but it is predicting correctly in the negative side of analysis. And false positive, you can say that outcome where the model incorrectly predicted in the positive class. So incorrectly predicted because is saying this manner, false positive, the prediction itself has a wrong. That is the reason we can say that incorrectly predicted in the positive class. And false negative is an outcome where the model is incorrectly predicted in the negative class. So incorrectly predicted means is what she is saying is a wrong answer. So that is the reason we can say it is a incorrectly predicted. So these are the four confusion matrix, actual class, then predicted class. Based on that, we can say that. And true positive, the model has predicted yes, and that's what just I'm elaborating again. True positive, we can see this one is a true positive. The model predicted correct only, and actual value also true. So if both is true, means prediction is yes, mean predicted correct value, and other also true. And whereas the true negative, what we can say, prediction is no, and then actual value also no. That will give true negative. And other one is false positive. The predicted yes, but actual value is no. That is a type 1 error. And false negative, the model has predicted no, but actual value was yes. This we call it as a type 2 error. So these are the, based on the confusion matrix, we can easily identify what is the value of true positive, true negative, and so on. Because when we go for as an example, we can see the numerical problems as well later point of time. Now we can see this actual, the dog and not a dog. What is the predictions and all? Need for confusion matrix in machine learning. It evaluates the performance of the classification model, because now we have to classify whether it is a dog or a not a dog. When they make predictions on a test data and tells how good our classification model is. In that, error may be classifies, error made by the classifiers, but also type of error such as type 1 error or a type 2 error, as we discussed in the previous slide. With help of the confusion matrix, we can calculate the different parameters of the model, such as accuracy. Another one is a precision. Example, we can understand the confusion matrix using this example. Now, this we call it as a true positive. This is a true negative, means this one, true positive, true negative, false positive, false negative. In that, it is a 2x2 confusion matrix is showing below, and image recognition having a dog image or not dog image. In that, now we can see there is a actual prediction result. By understanding this table, we can easily understand what is your confusion matrix. It is easy for you to understand confusion matrix. Suppose I given as a 10 instances, let it be. Then in the 10 instances, I pass the input, whether I'm passing dog or not a dog, something else also I can pass. In that, actually I'm passing first instant is dog. Next instant also dog, up to 3 instances are dog. Fourth instant, I'm giving something else, it is not a dog. Like that, this is the actuals, inputs, or you can say that. Now, what is the output? We are passing this inputs to the machine, or let it be ready model. Model is ready. There you are passing the input to say whether the given image is a dog or not a dog. Now in that, the predictions you can see. Prediction value, first instant I'm passing dog, it is telling dog only. That means what? Both are true. I can say true positive, and I'm passing dog second instant, but it is saying not a dog. That means it is a false negative, because the false negative, the total counts have predictions is not a dog, while actually it is a dog. In that case, we call it as a false negative, because it is actually dog, but prediction is not a dog. That is the reason I can say it is a false negative. So whenever both is same, then I can say true positive, and you can see other one, fourth instant. I'm not passing the input is a dog. Something else I passed, but it is saying that not a dog. It is correctly predicted. When it is correctly predicted, because not a dog is input, output also not a dog, then true negative. Why I call it as a negative version? It is not a dog. Actually, we have to pass the dog identity, that is false version. So that means in the negative class. So we can say that this we can say that true negative. And similarly, dog and dog, true positive. So here not a dog, but it is saying wrong answer. It is a dog, but I am not passing input as a dog. That's why false positive. And similarly, you can see in this table, we can easily identify what is the scenario of the result in a confusion matrix. So the result is true positive or true negative, false positive or false negative. Now, if I evaluate that, we got it as a the calculation part we have to do. This diagram directly will generate if we go for as a confusion matrix logic in the Python programming automatically that will give the result for you. Now, we can see how many true positives we got it in the previous thing. True positives, this is one, true positive, and then true positive 3, 4, 5. So there is a true positives are 5. I mentioned true positives are 5. Another one, false positive is 1, false negative is 1, true negative is 3. So these are the things. The data is from the observation here, from the results. Now, we need to go for as a calculation. Actual dogs I'm passing 6 because 1, 2, 3, 4, 5, 6. 6 dogs I passed. This is the actual dogs. And actual not dogs I passed 4. Total is 10. Then positive, true positive count is 5. False positive count is 1. From that, this matrix, confusion matrix is going to develop. Now, we'll go for as a calculation part. So what is the calculation? Calculation using as a confusion matrix. First one is accuracy. I mentioned no, in a matrix within a bracket accuracy, square mean error, square mean average, like that. So in the different category, I will go for as a matrix calculation. This is the parameter to determine the accuracy of a classification problem. What is the accuracy is? The formula of this accuracy is we can divide true positive because we have this true positive, true negative. Another one is false positive, false negative. You can see here from the previous one. True positive, true negative. Oh yeah, false positive, false negative. This is the false positive. This one is a false negative. Now, so this is the confusion matrix. In that, what you have to find is accuracy. Accuracy formula is, we can see that true positive, true negative. This column you can see true positive, true negative divided by sum. That will give is a accuracy of that. So in a true positive plus true negative divided by all the categories, true positive, false negative, true negative. So if I add that, you'll get it as a accuracy of your model is 80%. That means how best it is identified correctly. So based on your confusion matrix, we can easily identify the accuracy of a classification problem. And now we can see other one, misclassification rate, that is a error. Previous one is a accuracy. Now we'll go for as a error rate. This will be is a wrong predictions. Error in the sense how many are wrong. So now for that true positive in this side, as previously you can see here also available. True positive, false positive, and false negative, true negative. So in that case, we can easily identify false positive plus false negative, then divided by sum. These are all the false category, and this also false category. You sum these two, and then you can divide the total predictions, that we call it as a error rate. So now here error is a 20% and accuracy is a 80%. And other one, precision. It is also number of correct outputs provided by the model, or out of all positive classes that have been predicted correctly by the model. Now, how many of them were actually true? Now that is a precision. So true positive divided by true positive and false positive, that will give as a precision. Or you can say that recall. This also how model predicted correctly. That is recall must be as high as possible. So if it gives high, that means accuracy will be more. So calculate the recall true positive divided by true positive plus false negative. Here is a false positive. That is the difference between precision and recall. That divided by false negative. These formulas you must remember, because this is the confusion matrix. They may ask you to calculate the accuracy, precision, and recall and all. So now another one is F1 score. F1 score, because some of the parameters, like in the case of our power electronics and all, you have to analyze performance of the converter. Like that, in a model also, we have some of the parameters. F1 score that will give evaluate the overall performance of the classification model. So F1 score will be 2 into precision into recall by precision plus recall. These are the formulas. You just find the data based on the problem. And if two models have to precision and high recall, or vice versa, it's difficult to compare them model. So this purpose we can use F1 score as well. So now this F1 score is a maximum if recall is equal to the precision. Now other one is a specificity. In the specificity is the number of samples predicted correctly to the negative class out of all the samples. So these are the parameter you must remember. And other important term used in the confusion matrix, null error rate. These are the null error rate is the best classifier, has the highest error rate than the null error rate. And ROC is the graph displaying the classifier performance for all the possible thresholds. These are all the some of the recall in the y-axis, and then there is a performance in the x-axis. We can draw that. We'll get it as a, and these are all about the classification case. You can see that all about classification. Now we'll go for as a next one is a regression matrix. In the regression matrix, mean square error. This is the very oftenly used in the regression matrix. Mean square error is a perhaps the most popular matrix used in the regression problem. So classification and regression, these are all under supervised learning category. In the to find the model performance, or you can say that efficiency, all these things will go for as a classification problem, some of the parameters, and we'll go for regression model. We will use as a mean square error to average squared error between the predicted and actual value. That's what I given formula also in the previous. Mean square error 1 by n summation 1 to n yn minus yn cap. Yn cap is the prediction value and the output value, and square it, will get it as a mean square error. That is what I mentioned here. N is the number of data points or instances, and yn is the observed value. and yn cap is the predicted value. So based on that, we can easily, means if both is same, we'll get it as a 0 only, mean squared error. If any deviation is there, we call it as that is a mean squared error. And that is one of the parameter to measure this regression problem. And another one, we can see this squaring is critical. That is only the theoretical part. That is what we mention is in modulus is not mentioned. Minimize the mean squared error. Model could be more accurate. It could mean that model is close to the actual data. So whatever we predicted, the value is more or less same as the actual value, then mean square error will be very less. So it will go to near to the actual data. Linear regression using the least square method to evaluate the appropriateness of the linear regression model. For a vibrate the data set, that the limitations due to the known disturbances of the data set. This is one of the better for forecasting as well. Now we can see mean average error. So or absolute error. So mean absolute error measures the average magnitude of the errors in a set of predictions without considering their direction. So now we can see other formula, sum yi minus xi modulus divided by n, the average over the test samples of the absolute difference between predicted and actual observed value. All the individual differences weighted sum, we can say that equal to weight. And n is the number of data points, xi is the true value, yi is the predicted value. All error will get the difference of that. It is very meaningful. And disagreement and allow to disagreement based on the quality. It is possible to express the sum of two components, quantity disagreement and allocation disagreement. It is also possible to identify the type of difference looking for x comma y plot. If we draw this thing, we can see that the point x1 and quality difference in the x value does not equal to the average of y value. And allocation difference exists if and only if points resides on both sides of the identity line. And we can see the data points for which quality disagreement is 0 and allocation disagreement is 2 for the MAE and root mean square error also we can able to calculate. And the main reason for this is B is more attained and domains in the final error impacting the model parameters. So these are the some of the formulas root mean square error to find the value. So all these parameters will refer the quality of your model. That's what you can see that evaluation of the model root mean square error is commonly used in the climatology, in the forecasting, and then verifying it, standardization. So this example correlation coefficient is 1, that is root mean square will be the 0 because all the points on the regression line, it will be in line with the regression line. That means error will be 0. And these are all the some of the points evaluation of the model. And we'll stop this class today and we'll see some other class, next class. If you have any doubt, you can ask me. Otherwise, you can leave. So I will end the meeting. Now you can leave the meeting.